Okay, so welcome back. In this particular module, we will continue our discussion that we were having with construction and demolition waste management. So far, if you remember on the last few videos that we have on C&D waste, we started with looking at the C&D waste management rules which came out last year, 2016 from the Indian contest. We had a review of that rule. And then we also defined what is a C&D waste. We talked about construction waste, we talked about the demolition waste, and we looked at the different components, how they could potentially be recycled, what are the different products made out of those C&D waste, and then towards the end of the last video we also talked about some of this hazardous material which is present in C&D waste. So in this module we'll continue that discussion, and I'll talk to you a little bit about some of the challenges of managing C&D construction and demolition waste, and then we'll go into disaster waste. We'll talk about disaster waste, and I'll give you some examples of disaster waste management as well. Especially you will see lots of pictures, and as you saw from the introduction of this, during the introduction of this course, I did spend considerable amount of time in US, so most of the disaster pictures, unfortunately I don't have that much disasters picture from the Indian contest. It would be really great to have some, and I would request you guys, if you have some disasters pictures from different disasters happening and which happened in India over the past, please do share with me. I'll use those for people. I will not use it for commercial purpose. I'll not sell your pictures, but I can use it for my lectures, and if you allow that. So, but I'll give you the Hurricane Katrina right now as well. As a few weeks back there was a big hurricane in Texas, but Hurricane Katrina happened when I was just finishing up my PhD. So did had chance to work on Hurricane Katrina debris, so I'll talk to you about the Hurricane Katrina debris, show you some pictures, which is one of the disaster debris. See, it doesn't really matter which disaster, the basic concepts stays the same, whether we have the disaster debris in India or disaster debris in US or disaster debris from anywhere in the world. The basic concepts don't change, so it doesn't really matter too much, although some people may complain that there was not enough pictures coming from Indian contest, and I do agree with that. We should have some pictures from Indian contest. Unfortunately, I don't have some, so I could not show you that, but I'll talk about those. I'll talk about the Rishikesh incident. I'll talk about the recent incident that we had during this monsoon season as well. So let's get started, and first we'll look at some of C&D waste situation in terms of some of the projects, some of the challenges. One of the construction and demolition waste, and then here I am using one example, and this example is it can be for any waste stream coming out from construction and demolition waste, and this is for wood waste, and this is a specific type of wood waste which is known as CCA treated wood. CCA chemical, which is the chromated copper arsenate chemical, it is used as a treatment chemical for wood treatment to extend the service life of lumber for a longer period of time. As you know, during the hot and humid weather, in many times even in our campus here at IIT Kharagpur, we get a lot of termite attack. And we do termite treatment from time to time in our, especially at the ground floor apartments, ground floor houses, ground floor bungalows. But why the termite attack happens? So it happens because of the hot and humid weather. Those microorganisms, they grow very easily, and then they start attacking. If you are in a colder climate, you don't see that happening that much. It's because it's a colder climate, most of these biological activity doesn't really happen in cold weather. So that's why in case of hot and humid weather, we have to treat the wood. We have to treat the wood. Basically, we are infusing certain chemicals in there which are toxic to these termites and insects. So that's why they cannot come and eat those wood, and then our structure will be safe. With that concept, the CCA chemical, which is the chromated copper arsenate. So it has chromium, it has arsenic, and it has copper. So all three has certain roles to play in terms of wood protection. And CCA chemical was invented in India, although we don't use it that much in India anymore. We don't use that much of wood in India, especially in the construction sector. We do use wood for like our doors, windows and other stuff, and that too also we are going away from like a real wood, we are going for compressed wood, engineered woods and all that, because wood is very expensive in this part of the world. But if you go to the Western countries, they still use a lot of wood in the construction. So this when you use in construction, you have this wooden pole, say 4 by 4 inches by 4 inches or 6 like a big poles is sticking into the ground. So if they are sticking into the ground, they are getting all the ground moisture. So this termite attack is much easier. To prevent the termite attack, they treat the wood. So this is one example. This could be some other. This could be for some other waste stream as well. So when they are removed from service, for some reason they get removed from service. There are different ways it can be managed. It can go to a C&D debris recycling facility, and where it can be potentially recycled. Part of it can go to a municipal solid waste landfill, which is the lined landfill. Part of it can go to C&D landfill, which is you see more common. A C&D landfill is construction and demolition debris landfill. As I was explaining in the earlier video, most of the C&D landfill doesn't have the liner requirement. They don't have this liner. There is no liner there. So this liner is not present in C&D landfill, so no liner there. But if you go to the MSW landfills, we do have liners. So in the MSW landfill, you will see the liner being at the end of the liner that will prevent the leachate from going to the groundwater. So C&D landfill, although it is sited in a place with some clay at the bottom, so we will try to have a little bit of clay at least at the bottom, so that things but it's considered that most of the C&D material is not that harmful, so we don't need to have liner. Almost nearly 50% of the US states doesn't have liner for that. And then when it comes to the C&D debris recycling facility, it will get processed. So as you can see over here, the processing C&D processing facility, where it goes through different types of screens. They are called trommel screen. Other recycling process. Then you have processed wood. Processed wood could be used as a land application. Land application means mulch and those kind of stuff, or it can be also burned in a wood burning facility as a wood fuel facility. So this is what a typical waste management things happens for a construction and demolition waste, and so that's how it gets managed for C&D waste stream. So this is one example, and the reason I gave you this particular example is that my initial work was focused on this particular treated wood chemicals, and we did a lot of work on this treated wood. As you can see over here, the problem with this kind of wood is as the top, as you can see this picture, this is a mixed wood pile, a lot of wood, mixed wood, some lumber, some engineered wood and other stuff. Here mostly lumbers, and then here also it's a combination of lumbers and other things in there. So as you can see, that when it's weathered wood, when the wood gets weathered means it goes for several years of in service, the color changes to the silvery gray color. As you can see over here, this is mostly silvery gray color that you see in this particular place. But silvery gray color happens for all types. It doesn't matter whether it's a treated wood or untreated wood. So it becomes very difficult to identify. So to separate treated wood with untreated, because untreated wood is a good fuel. It can be made mulch, and you can do, like, there is no contamination. But when you talk about treated wood, which has some these heavy metals, you cannot really, there is certain things which you should not do. You should not just because you will end up contaminating the environment. So we did some a lot of research has been done in this area, and you can look at these research papers are available under my Google Scholar profile. So here we had some columns. This was a PhD of one of my friend, Jenna Jambak. She did work on this. These are her columns, and here she was trying to simulate landfill conditions for the different types of treated wood and try to see what will leach out, what is the environmental impact. So all these things are known as what is known as the risk assessment. We talked about that earlier as well. You are trying to do a risk assessment of disposal options, for recycling options, to find out how much it will leach and what chemicals it will leach out and what percentage of chemicals, percentage leaching is there. So those things can be ascertained by doing this kind of research. So a lot of construction and demolition debris stuff that you see, you have like a mixed stuff from the C&D, you have some mixed material. Here you see a picture of like a C&D recycling facility. I think you saw other same picture earlier as well. So, here you see a lot of people along the line on both sides, and they are looking at the C&D waste coming through, which comes through a conveyor belt at a very slow pace, and based on what kind of material it is, they drop off to these different kind of like a bunkers. So, it just gets dropped off at these bunkers, and then it gets collected and recycled. This picture that you see over here is essentially looking at a C&D debris landfill facility. A C&D landfill, if you remember, we talked about the gypsum wallboard, and we talked about the recycling of gypsum wallboard as well, which you saw this picture based on that earlier in one of the slides. But if you have traces of this gypsum wallboard, which is gypsum is calcium sulfate, and this sulfate in a reducing condition goes to sulfide, and then you have the hydrogen sulfide gas produced, which tries to get out of the landfill. So, here we are in this picture, we are trying to measure the flux. This is called flux chamber. So, we are trying to measure the flux of what is the fugitive emissions. What are the fugitive emissions coming out from the landfill going into the atmosphere from H2S. So, like how much H2S is escaping to the atmosphere. Because as you know that C&D landfills also doesn't have any gas collection system. So, most of the C&D landfills you will not see gas collection system. So, if there is no gas collection system, your H2S gas will try to emit out. And we do put some biofilter and other things on top just to keep it down, but it potentially this possibility is there that you will have H2S escaping out to the atmosphere. So, just a few examples to kind of show you the different things related to construction and demolition waste. This is another, this was a study done again few years back where we looked at the quantities of like this particular quantities of arsenic treated wood in demolition debris generated by Hurricane Katrina. So, now from C&D, construction and demolition, we are moving into disaster waste, which is disaster waste is more nastier than demolition waste because everything will get mixed up. So, in this particular research, what we tried to do is we looked at how much what is the quantity of arsenic that got released after this Hurricane Katrina. Now, if you think about from the Indian context, few years back we had the big that Kedarnath, that Haridwar, Rishikesh and all those slightly above Haridwar, from Rishikesh and on the way up we had a big natural disaster which generated a lot of disaster waste, and many of us watched those videos on our I don't know whether WhatsApp was there at that time, I don't remember, but we did see on the social media on Facebook and other places where even some cars just washing away, cars got washed away, many buildings just collapsed and part of the building got washed away as well. So, when you have those things coming into Ganga river and then ultimately it will come along the way of Ganga river, not only in Uttarakhand and then it will kind of come down on the plains as well up to some distance, and with this everything mixed up, you may have some heavy metals from different lights and other stuff. You can have some electronic waste, you could have some other kind of waste, engine oil in the house, where if it's grease, whatever, depending on what kind of job you do, then it all gets mixed up and then it gets disposed into the environment. So, although we will not worry too much about the arsenic disposal because we don't use that much that kind of material which has a lot of arsenic, but we do have to worry about say lead and other stuff in their nickel cadmium battery. So, all these went into the atmosphere. So, this particular research, since that Louisiana, Mississippi and part of Florida, these are very they have a lot of use of treated wood. So, since my research was on arsenic treated wood, so we thought that okay, let's try to quantify how much arsenic. We all are familiar with arsenic problem. The state West Bengal where I am sitting in, we have a lot of arsenic issues. Bangladesh has a lot of arsenic issues, and there are other parts of the country where we have arsenic issue as well, especially in the groundwater, which is a geogenic arsenic. But here we have CCA treated wood, which has arsenic, and we are dumping it into the C&D landfill. So, our concern was that if too much of arsenic is getting into the atmosphere, that will lead to the groundwater contamination at least like a few years down the line or maybe a few decades down the line. So, we tried to quantify it and then the study did get some publicity. It was put on top cover page the journal. Then also they did a news article on that. So as you can see, it was almost 10 years back, more than 10 years back, where this study was published. So so what we essentially did is in that north in terms of New Orleans, we found after our initial trip, we identified few hot spots. So we identified these 7 locations where we wanted to do some sampling. So we went around and did sampling. At each location we did at least 30 samples. So 30 wooden pieces we tested to find out whether there was arsenic treated or not arsenic treated. And then from the arsenic treated, we try to identify what should be the arsenic concentration. So based on these 7 sites, we had, and how we collected the data, we had this small toy, it's called XRF gun. So this XRF gun was used. It's around $35,000 toy, and you can see me. That's me, my younger version of your instructor for this course. And we took I went around and collected data for each of these sites, at least 30 samples, and many places actually we did much more than 30 samples, and to quantify how much arsenic is coming out. Then based on the total amount of disaster that is typically gets produced with this kind of disaster, there was some literature data available. So based on that, we has estimated how much wood will be there between among the wood, what percentage typically we see treated wood. So that data was also out there. So based on all that, we basically tried to estimate how much arsenic got released because of the release of this treated wood because of this treated wood in the environment. So in that case, we had the 7 sites. For the 7 sites, we had we plotted the data, and based on what we got, it's a slide in the x-axis. Here you see the site numbers 1 to 3, 1 to 7. On the y-axis, you see the arsenic concentration, and here you see these error bars. Error bars as the standard deviation for that. So it kind of overlaps with one another, and to a certain extent. And then we also had so all these sites, like 7 sites, we did that, and we found some information associated with arsenic release. So based on the 7 data sites, based on the amount of disaster debris typically got produced in this type of natural disaster, we had estimated that average arsenic concentration from the sample tested at CCA at 7 sites was 1740 metric ton. So this is 1740 metric ton from the debris generated in Louisiana and Mississippi. Just Louisiana and Mississippi, they had around 1740 metric ton of arsenic going into the environment. So now if this arsenic going into the environment, that raises concern in terms of what will happen to the groundwater source. So because it's going into the environment, so we are actually contaminating the groundwater. So that's always a question typically asked. And then since it's other option is just to find out how to manage it. So it's of course one aspect is looking at the environmental risk assessment. The other aspect is how to manage the risk. What we should do in terms of the risk management. So those things also needs to be looked into. Okay. So here are those 7 sites where we collected the pictures. The pictures have been shown for 9. Actually, there is some sites it has been duplicated. I don't remember which ones, but as you can see, there are these are the different places, and you can see all these disaster debris. So it was not easy. It was after Hurricane Katrina, things were really tough in that particular area. You see some volunteers trying to help out to clean up. This is again myself taking some sampling, taking the XRF reading. And then you see a bunch of disaster. This looks much cleaner, this picture, but otherwise you see all along lots of disaster debris, lots of disaster, and then waste, and all these disaster debris actually went to online landfill facility in the state of Louisiana. So that's always a concern in terms of the groundwater. So that leads to us to think about what is known as the potential for beneficial reuse. So when right now, as we have been talking about, the government is looking at housing for all by 2020 or whatever year, and we also, for the housing for all, what we need some raw material. Raw material can come from waste material, especially as we some of these waste, construction waste, demolition waste, if things are cleaner, they can be used as a potential construction material for any future construction. So, but when we go for doing that, what we need to make sure that it is environmentally safe to do it. So, we do not want to do something and then later on we find out that we actually created a mess. So, to prevent that kind of scenario, what we do is known as the beneficial reuse risk assessment. So, it is looking at, so then how we do it. So, if you have to say, if you are producing, you are a C&D waste producer, or you are a city engineer or a municipal or SPCB, CPCB, whatever role you have, or if you are a student, you may end up in those roles, and then you need to decide that this is a construction waste coming from this particular area. Can we use it for any construction material? Okay, is it okay to use it as a construction material? There are two aspects for it. One is the structural aspect, other is the environmental aspect. The structural aspect, of course, we can test, we can make, say, if you are making concrete, we can replace part of the aggregate with this recycled aggregate and look at the concrete strength 7 days, 14 days, 28 days on all those as per IS code. But and the other aspect which is gets neglected many times is looking at the environmental cost, environmental impact. So, if something is not like a clean and then we have to clean it before it becomes usable. So, in that while cleaning you are contaminating the water, and that contaminated water is going somewhere and contaminating something else. So, either a surface water or groundwater. So, those things we need to look at. So, in nutshell what we do is we look at must assess the risk to human health and environment. So, we have to look at the risk to the human health and environment. So, there are, and then we look at the multiple pathways and receptors may need to be considered. So, we look at what kind of receptors are there, whether if it is do we have a lot of animal activity, do we have a lot of bird activity. For example, Bharatpur Century, what we hear is now the type of birds coming into Bharatpur Century, the variety is going down. Many of these birds are not coming these days. So, this raises concern in terms of the typical ecosystem in that particular area. So that's that needs that also will be one of the receptor. We have to identify how the receptor we will choose. So, in terms of looking at use of waste material as a beneficial reuse, beneficial use or reuse, whatever we call it, we need to make sure that there is no risk to human health and environment, or there should be a manageable risk to human health and environment. And then there could we looked at what are the pathways, who are the receptors that needs to be considered. Like we have to look at the direct human exposure, contamination of groundwater, and as well as the impact on the ecosystem. So, those three aspects we need to look at in terms of coming up with like a risk associated with use of certain like use of certain waste material as a construction material. Waste is a misplaced resource actually. Waste as people I have a bit reservation calling waste to wealth, because the waste can create wealth, but it requires a lot of investment, lot of training, lot of everything to really make waste to wealth work. Because even today, if you go to Canada or Europe or anywhere, you have to pay for waste disposal fees. So, it's not really, they haven't been able to reach that stage where you can make so much money out of that it becomes kind of self-sustainable over a long period of time. So, they do rely on government support from time to time. So, similarly here there will be those kind of scenarios will show up. So, let us look at this beneficial reuse risk assessment, some of the basic concept. And in terms of the basic concept, one, if you have any industrial waste or construction waste or demolition waste, first thing you need to do is measure the total concentration. How much is the total concentration of the contaminant? You can also go for either XRD, SRF to find out what kind of metals could potentially be present there. And based on that, you look at the total concentration of those metals in this particular those metals in this particular waste stream, and then you measure the leachable concentration, because there are two ways things could be exposed when you have this hand to mouth activity. Like the small kids, when they go and play, they have a tendency to touch, like they will touch something and then they will put the same hand in the mouth. So, that is called hand to mouth activity. And since their hand is dirty with some of these heavy metals, which is in a dusty particle, and the kid is putting these fingers in their mouth without washing it properly, and that becomes your like a risk from things coming into your ingestion route. So first we need to look at the total concentration, what are the heavy metals presence and all that. Then we also measure leachable concentration. Leachable concentration is to find out what essentially actually leach out. So there could be certain elements which is present which will show up in our XRD in those results, but it may not leach. The leachability may be almost zero. So in that case it is still a risk from a direct human exposure point of view, from hand to mouth activity point of view, but it is not a risk when we talk about like in terms of groundwater pollution, or if you are using the water wells, it may not even go to the water wells, it will not leach out. So those things we need to find out. So total concentration, and then we do the leachable concentration. Then we compare the results on appropriate risk based thresholds, and the reuse application will get dictated by the results that we get. So these are some examples of different types of construction waste. Crushed concrete, which is again can be used back as a concrete or as a filling material. It's used a lot. Milled asphalt pavement. Asphalt pavement we talked about the other day. Asphalt is the bitumen. Asphalt cement is the bitumen actually, and this asphalt pavement is kind of everywhere in the world. So you can, once that some of this damage is there in the road and part of the road is taken away, that can be used as a milled asphalt pavement, and that can be sold off for different application. And chipped wood, we already talked about the wood, but chipped wood is the wood which is cut it down into smaller pieces, as the name suggests. So that is used either as a mulch, as you can see on this picture over here. That's a lot of you see some mulch which is used as a mulch, and this is some of the processing facility, and you have some other spray and other stuff coming up which shows up in this particular picture over there. Okay. And then this was another work where we tried to separate recovered wood waste using automated X-ray detector technology. So we had a X-ray detection which was we set up over there, and here essentially what will happen is this mixed waste stream of the wood waste will come in, and based on the result from this particular instrument, we can find out whether it's a treated or non-treated, and based on that we can divert it either to a treated pile or an untreated pile and use it for different purposes. So that's it has been developed and it is being under operational in South Florida. So that's where it has been used. Asphalt roofing shingles, we already talked about. That's a reuse as a asphalt. So there is no problem there. So in terms of this all these beneficial reuse risk assessment, we need to understand what exactly we are doing. So in terms of that's what we there is, of course, we try to simulate the conditions in the lab, and when we try to simulate conditions in the lab, one of the important tests in terms of beneficial reuse risk assessment for construction material, industrial waste is to look at our like how much will leach out and what that leaching test really mean. So in this particular paper, which is showing up on the slide right now, it's what we try to do is we try to interpret the synthetic precipitation leaching procedure, which is known as SPLP results for assessing risk to groundwater from land applied granular waste. So we had different types of waste being used, and that waste gives us some idea of how things are in terms of like a different like a beneficial reuse risk assessment side. So with that's kind of gives you a little bit of overview of the different kinds of projects, different kinds of stuff. Again, as I've been telling many times in this particular course, we need to be careful in terms of what we are getting out from here. My goal is, of course, to make you a critical analyzer in terms of different solid waste management options. That's what we have been trying to tell in this particular course, that you think that's very important. Like why? Always have that question why. Say for example, like we will try to do a compost plant. Okay, that's great, but why only compost? Why not some other processing facilities? How compost is better than other stuff? So those are things should come to your head. especially when you start working as a professional. So with that, let's okay, this is the last slide for this particular. This paper is available. It basically tells you what how to understand this SPLP result. So if you have any questions, always you are more than welcome to send your questions on the discussion forum, and we will be more than happy to respond to that. And I hope that you have also registered for the exam. So let's close this video, and then we'll get into the next video, which will essentially which will be lots of pictures, and that will complete the C&D waste management. So okay, thank you.